we can divide a polynomial by another polynomial and get a quotient polynomial and a remainder polynomial. Let's look at that. Let's also look at the comparison with regular division that you know very well how to do. Let's just take an example of 35 divided by 8 on the number side, and as far as polynomial division is concerned, let's take something x square plus 7x plus 5 divided by x plus 3. Now, how many 8s will fit inside 35? We know that 4 8s will fit inside 35. You will get 4 8s are 32. There are 3 more. We can't do anything about this 3. That's your remainder. The 4 was your quotient. The 35 is what we call dividend, and I'll refer to it as DD, and the 8 is divisor, and I'll refer to it as DS. What do we have an equation that links these 4 parameters together? We do. It's called Euclid's division algorithm, which you've learned in school, and if you have covered the remainders chapter, we see it again there as well. Basically 4 into 8, 32, plus the 3 will give you the 35. 4 into 8 plus 3 will give you the 35. That is quotient times the divisor plus remainder is equal to dividend. This is basically what Euclid's division algorithm is. That's the equation, but it's also this by itself doesn't fully explain division. You have to add a couple of pointers as well, that your quotient and remainder are integers. Also, remainder should lie between 0 and the divisor. It cannot be equal to the divisor, it has to be less than the divisor. We are familiar with this, and it has to be slightly adapted as far as polynomial division is concerned. We'll do the process. So how many x's will fit into an x square? X's will fit into it. X into x is x square, x into 3 is 3x, and when you subtract that, what you're left with is 7x minus 3x, 4x plus 5. How many x's will fit into a 4x? How many x's will fit into a 4x? 4 x's will fit into it, so that's plus 4, and then we do 4 into x is 4x, we do 4 into 3 is 12, and when we subtract you get minus 7. Now this is the dividend polynomial. It is a function, I'll call it dd of x. This is your divisor polynomial. This is your quotient polynomial, and this is your remainder polynomial. You will see that dividend is equal to quotient times the remainder, quotient times the divisor plus remainder is valid here as well. The same equation, the equation is the same. I'm just going to write that again. Dividend of x is divisor x times quotient x plus remainder x. Now just to add, this minus 7 is a constant polynomial. You can call it minus 7x raised to 0, and you'll understand why it can be written as r of x. Anyways, that is the equation. As far as the other conditions are concerned, when you divide a second degree, you notice that the dividend was second degree and the divisor given to you was first degree. The quotient you will get will also be first, it's going to be first degree, basically as the difference of this 2 and this 1. 2 minus 1, 1 is the degree of the quotient, and the rule for remainder is the degree of the remainder is less than the degree of the quotient. Degree of the divisor. You have your dividend degree and your divisor degree, you subtracted, the quotient degree should be that difference, and the remainder degree should be less than the divisor degree. These are the rules pertaining to polynomial division. This equation should hold. Also, the degrees, there are constraints on the degrees of all of the polynomials involved. We can look at one more example. Here is an example where the dividend is a fourth degree polynomial and the divisor is a second degree polynomial. Now this means that your quotient should have 4 minus 2 is equal to second degree, and your remainder should have a degree less than that. Degree of the remainder is less than 2. It can be 1 or 0. We cannot predict that yet. Let's do the long division and find out. First step, we'll put a term here that will completely remove the x raised to 4. X square, that will give you x raised to 4 plus 2x square. Notice it, because you don't have an x term here, you'll have to skip a space, a term. X square, and when you subtract this, you're gonna get 5x cube minus 5x square plus 4x. Now to remove the 5x cube completely, you have to put plus 5x. That's a 5x cube plus a 10x. When you subtract, you'll get minus 5x square minus 6x plus 7. You have to put a minus 5 here. Minus 5 into x square will give you minus 5x square. Minus 5 into plus 2 will give you minus 10, and when you subtract, you will get minus 6x plus 17. So the quotient you got was second degree, x square plus 5x minus 5, and your remainder was minus 6x plus 17. And so basically what we have here is equal to x square plus 2 into x square plus 5x minus 5 plus minus 6x plus 17 according to the division algorithm.